In this next lesson, we are going to be talking about polynomial division. So we're going to start with some problems that we are familiar with or somewhat familiar with, and then we're going to talk about long division and then synthetic division. Okay. Now, as we look at these first four examples, as we're looking at the directions, it says to simplify. And then when it's saying assume no variables are zero, this just tells us that we're allowed to simplify, and we don't need to worry about there being a no solution to our answer. Because remember, when we are dealing with fractions, we aren't allowed to have zero in the denominator. So if either of these variables were zero, that means that we wouldn't actually be able to simplify our problem. So that's why this set of directions is there. Okay. So as we look at problem 1, this is a review of what we did in our previous section. So as I'm looking at this, to simplify, 4 divided by 2 is 2. So that means that I will have a 2 in the numerator, and then technically there's a 1 in the denominator, but I'm not going to write it. And then if they have the same base, we are subtracting the exponents. So 7 minus 2 is 5, and then since there's 7 in the denominator, my simplified answer goes there. So I will have x to the 5th. And then on the y in the denominator, we're assuming there's a 1 there. So 5 minus 1 is 4. And there was more in the numerator, so that's where my simplified answer goes. So this would be my answer for that first problem. Okay. All right. Now as we look at the next problem, remember when we have a big fraction like this where we have addition and subtraction involved, if we're going to simplify the fraction as a whole, we have to divide the same thing out of every single term. And remember, terms are separated by that plus and minus sign. So as I'm looking at this problem, there are 4 total terms. So we have 3 in the top and then 1 in the denominator. So if I'm going to simplify this as a whole, I have to divide the same thing out of every single term. So as I'm looking at my numbers, so I have 6, 12, 18, and 3. Those are all divisible by 3. And then I want to look at the variables. So I have 4 x's in my first term, 3 in the second, 2 in the third, and then 1 in my fourth. So that means I can take 1 x away from each of those. And then as I'm looking at my y, so I have 3, 2, 1, and 1. So the most I can take away is 1 y from everything. Okay, so we're dividing each term by this. Okay, so if I start with this one, 6 divided by 3 is 2. And then I'm taking 1 x away and 1 y away. So this will be x cubed y squared. And then I go to my next term and do the same thing. 12 divided by 3 is 4. And then I'm taking 1 x and 1 y away. So this will become x squared y to the first. So I'll keep my minus sign. 18 divided by 3 is 6. Taking 1 x away and 1 y away. So this will give me an x. And then when I take this one away, I don't have any left, so I'm not going to write a y in that last term. And then as I look at my denominator, 3 divided by 3 is 1. And then we're taking both the x and y away. So when I have that big fraction, we never want to write it over 1 because that's not considered simplified. So that means that this would be my final answer. Okay. Now it's not always going to work out where we can divide by exactly what the denominator is. So as we look at our next example, that 8, 6, 10, and 4, those are only divisible by 2. So that means I'm going to have something left in the denominator. So again, if we were doing that, this would be, we're going to divide everything by 2. And then as I'm looking at my x's, I can take at least 2 away from each group. And then as I'm looking at the y's, I can take just 1 away from each group. Okay. So as I go through the division part, 8 divided by 2 is 4. And then if I take 2 x's away and 1 y away, I'm not going to have anything left in that term for the variables, so I'm just going to leave it as the 4. And then I'm keeping my sign. 6 divided by 2 is 3. and then I'm taking 2 x's away, so I'm going to have 1 left, and I'm taking 1 y away, so that will be y to the 4th. Okay. 10 divided by 2 is 5, and then for the exponents we are subtracting. So if I take 2 x's away, that means I will have 2 left, and if I take 1 y away, I'm not going to have any left. Okay. All right. And then for the denominator, 4 divided by 2 is 2. And I'm taking 2 x's away and 1 y away, so I'm not going to have any variables left. Okay. So this could be my final answer if we were simplifying that fraction as a whole. Now there is another way to approach these types of problems where we split the fraction up into as many terms as there are in the numerator. So if we were doing it that way, and how we decide is really based on the problem and how it wants the answer formatted. So we are coming up with equivalent answers. Now if we do want to break it up, so we're separating this into individual fractions, whatever your denominator is, you're just thinking that as underneath each of your terms in the numerator. So I'm going to rewrite that. So I would think of this as 8x squared y over 4x squared y, and then minus 6x cubed y to the 5th over that same denominator again, and then plus 10x to the 4th y over 4x squared y. Okay. Now if we split it up like this, then we're going to simplify each fraction on its own. So I'm simplifying this part, then this one, then this one. So if we did that, that means that this would cancel for the x's and the y's, and then 8 divided by 4 is 2. And then now I'm going to this one and doing the same thing. So 6 and 4 are both divisible by 2, so this will be 3 over 2 for the numbers. And then for the x's, I would have 1 left up in the numerator, and for the y's, I would have 4 left up there. And then I go to my next fraction and do the same thing. So 10 and 4 are both divisible by 2, so this will be a 5 over 2. And then I will have 2 x's left up in the top, and then the y's would completely cancel out. So this is another possible answer. So again, you'll just want to make sure that you're paying attention to how the question wants the answer formatted. So these are considered equivalent answers. And then for that last problem, when we have it set up like this, we would rewrite it to either look like this, or we would split it up into those individual fractions again. So again, based on what the question is asking for and how it wants the answer formatted is how you would choose to approach it. So I'm going to choose to separate it out like this. So that means that I would have 19 v squared z cubed divided by negative 4 v cubed z to the 4th, and then minus 28 v to the 5th z to the 5th divided by that same denominator, so negative 4 v cubed z to the 4th. And then I'm just simplifying each fraction individually. So remember, if I have a negative in the denominator, we need to divide both of these numbers by negative 1. So that means that this will become a negative 19 in the numerator and a positive 4 in the denominator. And then I will have a 1v in the denominator and 1z in the denominator. Okay. And then as I'm looking here, so these are both divisible by negative 4. So when I do that to the numerator, since we are subtracting a negative, that's going to become a positive. So this is going to become a plus, and then I will have 7 up in the numerator, and then 4 divided by itself is 1. And then I will have v squared in the numerator and z. And again, technically that would be over 1, but I don't want to write it like this. So my final answer would be negative 19 over 4vz, and then plus 7v squared z.